we are discussing equation of motion. First of all, before we look at, we have about three equations of motion. And this equation helps us to solve things connected to motion and mechanics. First of all, we'll be looking at what is acceleration, because it will lead us to the first equation of motion. We know that acceleration is the rate of change of velocity with time. That means acceleration, which is denoted by A, is the what? Rate of change of velocity with time. And if we say that acceleration is the rate of change of velocity with time, we know that now for us to get equation of motion, we have to further simplify this and make V the subject of formula. For us to simplify this equation, we now have to cross multiply, which will have A t is equals to V minus U, where we have V is equals to U plus A t. This is called the first equation of motion. And the first equation of motion is gotten from acceleration. Are we together? So you discover that from the definition of acceleration, you make V the subject of formula. Now I want to look at the second equation of motion. And we know that the average velocity is equals to U plus V all over 2. Now, let's call this one equation 2. If this is this, substituting equation 1 into equation 2, we have that the average velocity, which is U plus, instead of V, we put equation 1, U plus AT all over 2. Where we go further to simplify it as 2U plus AT all over 2, which will go further to say that 2U all over 2 plus AT all over 2. Are we together? Now, if we go this way, we discover that 2 cancel 2 here. We now have the average velocity to be equals to U plus AT all over 2. And therefore, remember that distance is average velocity times time. Distance is average velocity times time. So it implies that distance is what? Average velocity times time. Now bringing this, which we call this equation 3, bringing equation 3 into this, we now have that S is equals to U plus AT all over 2 times time. So it implies that we have our distance, which is S. We now have this multiplied by this, we have 2U UT plus AT squared all over 2. It can be written popularly as the same as this. Distance is equals to 2UT plus half AT squared. This is our second equation of motion. Second equation of motion. Now, to go to the third equation of motion, we have to use equation 1 and equation 4. We know that equation 1 is V is equals to U plus AT as equation 1, and we have distance is equals to UT plus half AT squared. First of all, before I go further to explain equation 3, I know that you know what this symbol means, where we say that where T is what? Time. V is final velocity. U, initial velocity. A, acceleration. Now, if we understand this concept that these are the things we are working in, we therefore now look to get the third equation of motion. We go further to say that let's square both of equation 1. That means that we have v squared is equals to into u plus at squared. We go further in opening the bracket. You know how to open bracket very well. It's what we did in SS1 and GS3. We come to say that u plus at, open bracket again, u plus at. Now we go further to say v squared is this times this will give you u squared plus, because of the sign, this times this will give you uat plus, this times this will give you uat plus, this times this will give you a squared t squared. We go further to simplify by u squared, because this and this are the same, become plus uat plus a squared t squared. Remember that we want to do a small simplification. Remember that we are using this equation 4. Now we go further to expand it by saying that u squared plus a 2a into ut plus at squared all over 2. You discover that this is the same as this. So in this, we replace this with x. We'll now go further to say that u squared plus 2ax. We'll now come to a conclusion that our v squared is equals to u squared plus 2ax. This is now the third equation of motion. In this equation of motion, if they give you any parameters, velocity, initial distance, acceleration, you'll be able to solve equation in motion.